All right, so today we are going to start section 1.3, and we're going to do the multiplying monomials today. So a monomial is a number, a variable, or a product of a number and one or more variables. And it's actually another word for power. So we talked about this yesterday, and now we're actually going to be using multiplication properties to simplify. So for multiplying powers, the first thing we're going to do is I'm going to show you how we write each product in expanded form, and then how we rewrite it in exponential form. So if we have x squared, that's like x times x. And if we have x cubed, we have x times x times x. Okay? If I want to multiply all those together, I actually get x to the fifth. Okay, to simplify that, we would get x to the fifth. So I want you to kind of notice a pattern we have, and then I'll show you in the next product property what I'm talking about. So for this next one, we have 2 to the fourth times 2 to the third. So I'm going to take 2 times 2 times 2 times 2 and multiply that by 2 times 2 times 2. So I have my two groups here. If we multiply that all together, how many are there together? There's 7, so we get 2 to the 7th. So if you noticed, 2 plus 3 is 5. 4 plus 3 is 7. So this leads us to the product of powers property. So what we did here is to multiply powers with the same base, we add their exponents. So if you have two powers and they have the same base, so this one has A, this one has A, then you can add their exponents together to get your new exponent. They have to have the same base. So for example, 1, I have 8 to the fourth times 8. Now 8 is all by itself, but what's really there is an exponent of 1. So when I do this, I'm actually thinking 8, and I'm adding 4 plus 1. So our answer is going to be 8 to the fifth power. They do not want you to simplify it anymore. You're going to keep it with an exponent. All right, example 2. So we have 9 to the third times 9 squared. So I'm going to take 9, and then I'm going to add 3 plus 2. When I do that, I get 9 to the fifth power. Leave it with an exponent. All right, example 3, r to the fourth times r to the sixth. They both have a base of r, so I'm able to use the same rule. I'm going to do 4 plus 6. When we do that, we get r to the 10th, and that's our answer. All right, moving on to a little bit more complicated problems. We have coefficients added in. Coefficients are numbers in front of the variable. And then for some of these, we have more than one variable. So we're going to have to make sure we multiply the numbers or the exponents with the same bases. So for the first one, I'm actually going to use some different colors for this. So here we have a coefficient with -3 and a coefficient of 4. So we're going to take that -3 and 4. They're like terms. They're going to multiply together. Okay, so I'm actually going to write -3 times 4. Then we have another like term set. We have the x squared and x to the fifth that go together. So in parentheses, I'm going to put x squared times x to the fifth. So now you're going to multiply like normal for these numbers. -3 times 4 is -12. X squared times x to the fifth, we keep the x because it's the same base. 2 plus 5 is 7. So our final answer is -12 x to the 7th. right, for example 5, I think I'm gonna need a few more colors for this one. So let's start here. I see a coefficient in front, so -2, -6, -2 times -6. Then we have A's in both. So we have a to the 4th times a to the 2nd. Then I see a b in both, b to the 3rd times b. Remember, this is b to the 1st. And hopefully I have room here. We have c and c to the 4th. Remember, this is a 1. So we have c to the 1st times c to the 4th. Okay, we're gonna simplify these. So I'm gonna start here. -2 times -6 is +12. A to the 4th times a squared, same base. 4 plus 2 is 6. B to the 3rd times b to the 1st, same base. 3 plus 1 is 4. And for the C's, same base, so we add the exponents. 1 plus 4 is 5. So that is our final answer because we can't simplify it anymore. All right, for this next one, I'm going to draw a little line here. Keep these separate. All right, so same type of thing. We're looking at like terms. So I see a -9 and a 5. It's equal sign. All right, I see a common like terms with the x's. So we have x to the 6th times x squared. So when I multiply this, we get -45 times x's are the same base. 6 plus 2 is 8. So we get -45 times x to the 8th. All right, so this is just the property you're gonna work with today. So please make sure you're paying attention to like terms. Numbers multiply with numbers. Bases need to match in order to add the exponents. This is all multiplication today, okay? If you feel on your homework that you need to underline like I did or use different colors, you're more than welcome to, whatever helps. And if you have any questions, please reach out. All right, thanks.